Hello students, myself Ankita Shukla. Today I brought for you Physics class 9 chapter 2 Force and Laws of Motion. Before starting the topic, I would like to request you please subscribe our school YouTube channel and click on bell icon to receive the future notification. Now let's come back. In this video, there are two topics I will explain: Newton's first law of motion and inertia. Actually, Newton's first law of motion is also known as law of inertia. So, both the topic I will explain. Now, first, Newton's first law of motion. Some of the bodies around us are at rest, that is, they are stationary, whereas other are in motion. So Newton's first law describes the behavior of such bodies which are in a state of rest or in uniform motion in a straight line. So according to Newton's first law of motion, a body at rest will remain at rest and a body in motion will continue in motion in a straight line with a uniform speed unless it is compelled by an external force to change its state of rest or of uniform motion. In simple words, we can say if a body is in rest, it will remain in rest. If a body in motion, it will remain in motion unless any external force are applied on the object, or of the body. For example, let us take some example to make the first law of motion more clear. Suppose a book is laying on the table. Suppose a book is laying on the table. It is rest. The book will not move by itself. That is, it cannot change its position of rest by itself. It can change its state of rest only when compelled by the force of our hands, that is, when we lift the book from the table. Thus, the position of rest of the book has been changed by the external force of our hand. Now, our hand. Newton's first law, and in other words, the second part of the Newton's first law means if a body in motion, it will remain in motion. This part of law may appear wrong because as we see in our everyday life now, that a moving body always comes to rest and does not move forever. However, if the problem is analyzed closely, we come to the conclusion that moving bodies on the surface of the earth come to rest. Why? On account of the force of friction applied by air or earth or both, and the acceleration due to gravity. But the present day space probes have proved beyond doubt that a body will continue moving forever in a straight line when the forces, means force of friction, acceleration due to gravity, all forces are absent. A recent example of this is the launching of Pioneer 1st and 2nd, which will ultimately move out of our solar system. So now in this basis we can say if a body in motion, it will remain in motion unless any external force applied on the body. Now there are more another example which are on your screen. There are 4 figures. First, there are football which in at rest, it will remain at rest unless in second figure a footballer kick the football. After this, football comes in motion and it will continue in motion, yeah, it will remain in motion unless acted on by an unbalanced force. Now inertia. What is inertia? Anything or material is incapable of changing its state of rest or of uniform motion on its own, and hence is in the state of inertia. Now I am going to repeat. If anything or material is incapable of changing its state of rest or of uniform motion on its own, and hence it is in the state of inertia. In other words, we can say inertia is that property of a body due to which it resists a change in its state of rest or uniform motion. Means the tendency of a body to remain at rest, or if moving, to continue moving in a straight line is called inertia. For example, when a running car or bus stops suddenly, the passengers are jerked forward because due to inertia. The passenger tends to remain in their state of motion even though the car or bus has come to rest. Now next, types of inertia. There are three types of inertia: inertia of rest, inertia of motion, inertia of direction. Now first, inertia of rest. The tendency of a body to continue in its state of rest even when some external force is applied on it is called the inertia of rest. Now second, inertia of motion. The tendency of a body to continue in its state of motion even when some external force is applied on it is called the inertia of motion. Now inertia of direction. The tendency of a body to continue in its state of direction even when some external force is applied on it is called inertia of direction. Now there is example on your slide. There we take a glass tumbler and place a thick square card on its mouth. A coin is also then placed above this card in the middle. Let us flick the card hard with our finger. Let us flick the card hard with our fingers. On flicking the card moves away, but the coin drops into the glass tumbler. How? Now I am going to explain how it happens. Initially, both the card and the coin both are in state of rest. Now when we hit the card with our fingers, when we flick the card with our fingers, a force acts on the card and the changes its state of rest to that of motion. Due to this, the card moves away from the mouth of the glass tumbler. The force of our flick, however, does not act on the coin. So the coin continues to be in its state of rest due to its inertia. And when the card moves away, the coin falls into the glass tumbler because it prefers to maintain its state of rest due to inertia. Now next, inertia and mass. Actually, mass is a measure of inertia of a body. Means if a body has more mass, it has more inertia. If a body has less mass, it has less inertia. Greater the inertia of a body, greater will be the force required to bring a change in its state of rest or uniform motion. Heavier objects have more inertia than lighter objects. That's why when body have more inertia, it required a high force to change its position, means state of rest or uniform motion. For example, a stone has greater inertia than a football. A stone has greater inertia than a football. If we kick a stone, it will not move because of its high inertia. But if we kick a football, it will move a long way because it's a less inertia. Similarly, a cricket ball has more inertia than a rubber ball, which you are on screen. There are two balls now, one of blue colors and one of green colors. Means blue color of the bowling ball means cricket ball and green color ball is the rubber ball. So a cricket ball has more inertia than a rubber ball of the same size. So cricket ball has more inertia because it has more mass, and rubber ball has less inertia because of it less mass. The inertia of a body depends on its mass. So the bowling ball has, because it has more inertia, so it required more force in comparison to the rubber ball. Means bowling ball has required more force in comparison to the rubber ball. Why? Because it has more mass and it has more inertia. Another example, if a body has mass of 1 kilogram and another body has mass of 20 kilogram, then the body having 20 kilogram mass will have more inertia. So it is easier to move a body of mass 1 kilogram by pushing it. But it is much more difficult to move a body of mass 20 kilogram by pushing it. So those objects which have less inertia, it requires less force. Those objects which have high inertia, means high mass, then it required more force. Now thank you for watching.